Welcome to Mathematics with Tom. I am Tom, and today I want to try to give you an intuition behind the function e to the t. Why e to the t? Why does it solve the differential equation of y prime of t equals y of t? Well, here's an interesting idea. Suppose maybe we just wanted a polynomial. Here's y. So let's say that y of t equals 1 plus t. Well, notice this. If I take the derivative y prime of t, well, what do I get? I just get the 1 becomes a 0. The derivative of the t, that's just a 1. Well, these are not quite equal because notice that I'm off by a term. I don't have a t. Well, let's try this again. What if I said y of t is 1 plus t plus 1/2 t squared? Then when I take the derivative of this third term, that's going to give me back to this term. So let's try this. So then y prime of t, that's the first is going to give me a 0. The derivative of the t is a 1. The derivative of 1/2 t squared, well, that's just going to be t. Oh, but wait a minute. I still don't have that third term. What I'm missing is this piece right here. So again, y prime does not equal y of t. Well, what if we try it, for the sake of illustration, one more time? 1 plus t plus, I'm going to write this as t squared over 2 plus, now what I want is I need to get something t cubed, and I'm going to put it over 6, because now when I take that derivative, let's see what happens. Y prime of t, now I get a 0, then I get plus a 1, plus a t, that's going to give me the 3 over the 6, that's going to reduce to a 1/2, so there's t squared over 2. And look at this. Now, this y here, its derivative gets you back to that y. But again, I still fall short of this term. The idea behind this, always needing one more term, is one of the derivations, I guess you could say, of e to the t. And that is let's just say we had an infinite number of these, that we have y of t equals 1 plus t, and let me just write it correctly, plus t over 1 factorial plus t squared over 2 factorial plus t cubed over 3 factorial plus, and we could keep going. If you have t to the 4th, you're going to have over 4 factorial. So when you take, for example, when you take the derivative, the 4 here cancels out the 4 in the 4 factorial, which takes you down to the 3 factorial and takes you down to the 3rd power when you take the derivative. But this just keeps on going. If it goes on forever, then I never run out of terms, and I always pick up that last derivative. It's this infinite polynomial with the increasing powers over the factorial of the power that gives you the function e to the t. And, for example, you can estimate e very easily. I mean, you might know what it is. For example, you could say that e to the 1st power, and t is 1, well, you could just, if you wanted a quick approximation, you could say that this is 1 plus 1 over 1 factorial plus 1 squared over 2 factorial. Well, I think that should be enough, but let's see what this gives me. This is going to be a 1 plus a 1 plus, that's going to be 1 squared, that's 1, divided by 2 factorial, that's 2, that's just a 1/2. So, oops, I should have an approximate sign here. It's approximately 2.5 or 2.5. And that's getting pretty close. The actual number is 2.718, and it goes on forever. If you wanted to approximate it even closer, Or you could take out to a third term. Or maybe you wanted to find out what e squared is approximately. Well, you could say that, I'm just going to use, I like the double wiggly. So there's an approximation. So this would be 1 plus 2 over 1 factorial plus 2 squared over 2 factorial. And I'm going to stop there, but this would sure get me close to probably what e squared would be. Well, I have a 1 plus a 2 over 1 plus 2 squared, that's 4. 4 divided by 2 is 2. So 5? Is e squared close to 5? Well, you could always add another term and just find out how much closer you want to be. So that's one of the ideas behind the function e as the infinite series. And we write this as e to the t is equal to the summation as n goes from, let's say, 1 to infinity of 0. Let's go from 0 to infinity of t to the 0 over, t to the n over n factorial. And that is how e can be written as an infinite series or a never-ending polynomial. I hope that helps. Thanks for watching.